Hey everybody, it's Mr. Chris at the Hudson Area Public Library. We are doing another short video to go with our, these were bags that were leftover materials from our virtual camps we did this summer. So this one is on water filtration. And we're just doing this short video to help explain all the materials that are in your kit bag because since it's not part of the camp, we're not talking on the Zoom and doing all the added materials we had. It's a little hard to figure out everything just from going through the bag. So as before with these, I'll just share my screen for a few slides that kind of explains what's all in your bag and the science behind it, and then some little tips on how to achieve a successful experiment for yourselves. So let's see if we can share this, and we'll just do a quick version of what I have here. So water filtration, and we'll present. Okay, so hopefully everybody can see that. So water, as you might guess, is kind of heavy. If you've held a glass of water or a pitcher of water, or if you have rain barrels at your house for storing rainwater for gardening, water is heavy. And it's really heavy when you need a lot of it, like large volumes of water, bathtub size volumes of water. And that all has to be, for example, for astronauts on the International Space Station, the water they drink and they use for food on the International Space Station has to be flown up on rockets, like you see pictured here. So depending on the rocket you're using, which country is flying the resupply mission that month, it's between $3,000 and $5,000 per pound of anything you send up. So sometimes they're sending up clothes for everyone and new science experiments or tools to fix things that have broken on the space station. And sometimes it's food and water. And so whatever it is $3,000 to $5,000 per pound. So for a pound, a good reference, if you've been to the grocery store, sometimes they have those nice scales where you can weigh vegetables if you're trying to figure out how much you've picked. So a good size apple or a couple of bananas, something like that, is equal to a pound. So if you can imagine when they send up apples to the astronauts as part of their fresh fruit or vegetables they're sending up on a resupply mission, those apples costing like $3,000 to $5,000 per apple is pretty much what it costs. So that's crazy expensive. And NASA's always looking for ways, the engineers that work there, to try to get those costs down and to make the space station more efficient. And one of those ways is in recycling, reusing the water. So we'll talk about that in a second. This is an example of a meal they might have on the International Space Station. This is what it looks like when it's all packaged up and ready to go. So they have silverware there with little pieces of Velcro on it. Those are the black strips you see are magnetized in this case. So it can be little magnet strips making the metal object sticks. They have scissors for cutting open their bags of food. And some things you might recognize, like the M&Ms, Skittles, little butter cookies for things like that, crackers. And then the other packets are things where they have these little attachments on the top where they can inject water. So it might be a pasta dish, mac and cheese, spaghetti, things like that. They can hook it up and add hot or cold water, depending on what's recommended on the label on the container, mush it all together and mix it up. And then they have hot mac and cheese or spaghetti or whatever it is. So to keep these things light, they're all vacuum packed, which is why they have the wrappers where they've taken all the air and sucked all the air out of the package. And sometimes they use dehydrated foods like these packages where they're going to add water to it later. And if you've ever had, sometimes at the grocery store, you can get dehydrated strawberries, different dehydrated fruits. They're very light in the bag because they've taken all the moisture out of it. So that's one way to cut down on the weight. You can send more things up if they're in this kind of freeze-dried, dehydrated, vacuum-packed way of doing things. That's one way we take advantage of keeping the weight down. The other is what I mentioned before. They do get some fresh fruit and vegetables because they don't have a refrigerator or a freezer to use for that on board the International Space Station. They do get sent up every time there's a resupply flight. They'll send up some fresh fruit and vegetables and put those right by the hatch when they open the door. So that gets back into that really expensive per pound what they're sending up. So I'm not going to go into this too much in the graphic, but two words to kind of remember, two terms, is an open system and a closed system. And so as you'll see this kind of oval circle on the International Space Station, they're trying to get to more and more of a closed system. And that closed means that you have everything you need. You don't need anything from the outside. So if you lived on a farm, for example, you might be able to get almost everything you need just from your farm. And you wouldn't need to go to the grocery store or get outside supplies. You could have your milk and your eggs and your food and your fruit and your vegetables and everything right there. And that would be getting close to that closed loop. So the International Space Station isn't quite there. There are still resupply missions, but they're trying to get better and smarter at recycling water. And that's one of the big heavy things to send up. So the way they do that, they've developed equipment where they can, when you exercise, when you sweat on the International Space Station, they reclaim that moisture out of the air, they filter it and turn it back into drinking water. They can do that with the leftover water in their food meals they're preparing. So breakfast, lunch, or dinner, if there's leftover drinks or fluid in the food, they pull that out and filter that and turn that back into drinking water. Another thing they're doing on the International Space Station is growing plants, experimenting with growing our own food so that we could get produce, just like if you have a garden at your home. They're trying to do that on the space station so that we could produce more food that the astronauts could eat on the space station. And this is an example of some of the zinnia flowers they've grown. And that's what the International Space Station looks like right now. At any given time, there are 3 to 6 astronauts living on the space station. There's always somebody up there 24 hours a day, 7 days a week for the last 20 years. So this is that water reclaiming system. So these are in racks up on the International Space Station. This is a test version that's on the ground where they're seeing how the equipment works and how best to optimize it. But this is all the equipment that kind of pulls all that moisture out of the air, reclaims it from sweat, reclaims it from food, reclaims it from when you go to the bathroom. They take all that moisture and turn that back into drinking water again. And then these are the things we were talking about before with the exercise stations on board. So when you're exercising really hard and you're sweating, you're going to be producing that water. And then these are the machines that reclaim all that water and filter it out. Astronauts eating the food like we talked about. And then the all-important water. So this is what happens to a droplet of water on the International Space Station. It kind of turns into a lens, turns into a round sphere when it's weightless, and the astronauts have some fun playing with that. So those are the slides I wanted to share. And what you're going to be working on with this activity is everything you need in here to do a water filtration experiment. So you'll find a lot of supplies. I'm not going to go through every single one of them, but just the main procedures and what you'll be doing. This is the container that you're going to make your dirty water, and this is what you're going to be practicing, pretending it's gross water that you need to filter and try to get just good drinking water out of. So this big 2-liter empty bottle is where you're going to be putting all your stuff to make it not nice. And you have some supplies for that. So you have animal crackers and cheese balls. You have dirt you can put in. You have Italian salad dressing, which has all that great stuff floating around in there. So those are some examples of the things you're going to be putting in your nasty water solution. And then on the other side, you're going to be having another smaller water bottle that we cut for you already. Take out this bag. And you're going to be making a filtration system. So it's going to kind of go like that. So your levels of filtration are going to go in this container. You have several things like that. You have filters, marbles, sand, packing peanuts, things like that. You're going to layer those in there. Then when you have it and you're ready to go, you're going to remove the cap, place it inside the other part of the bottle, and then you'll pour your nasty water solution through the top there, and then you'll let it filter through and then see what quality the water is that you get in the bottom of that chamber. Now, no matter how clear the water is, This is not for drinking. This is for an experiment. So you should not be drinking any of the dirty water solution that you make in the green container. And no matter how clear it comes out, you're not going to want to drink anything in that. It's just an experiment to see, can you remove a lot of the pollutants in that water you're making and get something approximating like what they do on the International Space Station for doing that. And then you'll have a few different ways you can do that. So you'll have your paperwork here and you have tracking sheets. So you can kind of do 2 or 3 different combinations. You can clean this out, rinse this one out, and then start again with 3 different things. Like maybe you want to use the marbles and the coffee filters and something else on the next one and see, did that do better or worse than your previous experiment? And finally, you'll have little pH strips. Those of you that have a pool or access to a pool, sometimes you use pH strips to check the quality of the water in the pool, and you will use the pH strips. You have a whole booklet of them in there where you can dip it, it'll change color in the water, and then you can compare that to the little color chart and see how much pH, what the pH balance is in the water. So you're trying to bring the pH number to something closer to what it is in regular drinking water and do that. And then that would be giving you an approximation of the work that they do on the International Space Station for astronauts to try to take all that gross water that's left over from food or other things and turn it into something that's drinking water for the astronauts to use. And the water they get actually on the International Space Station is purer than anything we get here on Earth. So it doesn't matter how expensive the water bottle you buy at the store is, they're getting the purest water that can pretty much be made is on the International Space Station. So they do a very good job of it. They're getting better every year, and that technology helps people here on Earth because it helps us purify water from like a bacteria-filled well, or if there's dirty water that has a lot of microbes and bacteria in it for a community. These processes that we're using on the International Space Station have helped communities here on Earth get good, clean drinking water. They also make it for camping products. There's a company called Life Straw that uses this technology that they kind of figured out for the International Space Station. So campers carry it because if the only water that's nearby is a river or a stream, and you're not sure if there's any microbes or bacteria in the water, if you drink through the Life Straw, it'll purify the water for you to be able to safely drink it. If you're out where there's nowhere nearby, to get a fresh drink of water. So fun science experiment. Would love to hear your results. So again, I'm not seeing everybody with the camps with the kind of current virtual situation we're in, but if you do the experiment, we'd love to see, like if you want to send a copy of your experiment sheet in, we'd love to post that and see that. And that's about it. I hope you enjoy the experiments in there and hope you have fun with it. You're all having a great summer. And if you do another one of these, we'll have a few more rolling out here as we get towards September. So thanks a lot. See you soon. Bye.